In this demonstration, I will show you what is hollow process injection, and I will also show you how a malware performs hollow process injection. But before we reverse engineer the sample and try to understand how malware performs a hollow process injection, let's try to understand what is hollow process injection. Hollow process injection is a code injection technique in which a process executable section in the memory is replaced with a malicious executable. So how does it work? So there is a malicious process which creates a legitimate process. Let's say it is svc host.exe in the suspended mode. Okay. As a result of that, the process is loaded into the memory. Okay. And the process executable itself is loaded into the memory. Okay. Let's say it is loaded here. Okay. So because the process is in the suspended mode, the main thread is not executing. Okay. And then the next step, what the malware process does is it finds the code that it wants to inject, which is a malicious code, which is normally a malicious executable. So this executable can come from the resource section of the malware itself, or it can come from the network, or it can come from the file on the disk. So once it finds the executable that it wants to inject, the next step is to deallocate the memory where the legitimate executable is loaded. So what malware does is it deallocates the memory of the legitimate process process executable, and then what malware does is because it has to inject this executable into this remote process memory, this malicious process have to now allocate a memory in the remote process, and this allocation can happen in the same place where the legitimate executable was loaded before, or it can be allocated in a different location. Now this allocated memory will normally have a permission of read, write, execute. Okay. And once it allocates a memory in the remote process, which is a legitimate process, it injects the code, the malicious executable, into this allocated memory. At this point, what happened is the process was hollowed out and its executable section was replaced with the malicious executable. Okay. So there is one last step. If you remember, I told you that the process is in the suspended mode, which means the main thread of this process, which was a legitimate process, was suspended. Now, what it has to do is the start address of this main thread, the start address of this suspended thread, will now be pointed to the address of entry point of the malicious executable, and this thread which is suspended is now resumed. As a result of that, this legitimate process now starts executing the malicious code which is injected where the legitimate executable was loaded. Okay, this way the malware can perform malicious actions within the context of the legitimate process. And also the malware authors use this technique so that they can disguise the malware process with the legitimate process. Okay, and also if you look at the path of this executable, okay, the path of this executable will still be pointing to the legitimate path. Let's say if it was svc host.exe that was hollowed out, the path of this svc host.exe will still be pointing to C Windows System32 svc host.exe. Thereby, it does not create any suspicion in case if a system administrator or a normal user is looking at a process, trying to find any process which is running from a non-standard path. So this is the overview of how the hollow process injection works. Now let's go back to our Windows machine, and this is where let's try to understand in detail how a malware performs hollow process injection. So this is a malware sample called hw, which has a file name of hw.exe. This is the malware sample that we will be reverse engineering. Okay, and also for the sake of reverse engineering, I will set breakpoints at multiple interesting places. Okay, let's debug the malware. Okay, so I'm debugging the malware here. As you can see, we landed on our first breakpoint, which is the address of entry point of the malware. Okay, so let's see what malware does. Okay, so the first thing that the malware is doing is it is calling a function which I've renamed it as getResource because I know what is the functionality of this function. So based on that, I've renamed this function to getResource. So just to give an overview, this function is responsible for getting the malicious executable that it wants to inject from the resource section of this executable. Okay, so how does it do that? Let's try to see that in detail. Okay, so let's get into this function and see how it does that. So the first thing the malware does is it is trying to find the resource whose name is localization and the resource type is Unicode. So basically it is trying to find a resource from its resource section. Okay. In order to understand what is this, we can use a tool called Resource Hacker. So what I've done is I've opened this executable in a tool called Resource Hacker, which shows the resource section. As you can see, there is a resource with the name localization and the resource type as Unicode. And this is that resource here. As you can see, this is the resource that the malware is trying to find. Now this is in the resource section of this executable hw.exe, which is the malware that we are debugging. Okay. Now let's see what malware does next. So once it finds the resource, the next thing the malware does is it is trying to call load resource so that it can find the resource in the memory. Okay, so once, and then it also calls lock resource. Using this API call, it can find where this resource is located in the memory. After you execute, you'll see that in the EX register here is the return value, which tells you where this resource is located in the memory. So let's synchronize that with EX register. And you see that here 406084 is where the resource is located. As you can see, 0C1B D1, this is the resource that is actually in the executable. So now at this point, the malware found the resource with the name localization and the type as Unicode. Okay. So next, let's see what malware does. So the malware next calls size of resource API call to find the size of this resource. And after running this function, you will see that the size of this resource is 6000 in hexadecimal, which turns out to be somewhere around 24.5 KB. Okay. So now we know that the size of the resource is 24.5 KB. Okay. So next, what malware does is it allocates a memory whose size is, as you can see, it uses virtual alloc API call to allocate a memory, and it is trying to allocate a memory of size 6000 bytes in hexadecimal, which is the size of the resource. So, and you should see that after I run the function here, you see that the memory is located at this particular address here, 00350000. Okay. And then what the malware is doing is it is copying the content of the resource. Okay, this is the destination where it's going to copy the 35,000 here. You see here, this is where it's going to copy the content of the resource, which is here, the second parameter here. Okay. So you see here, this is the content of the resource which the malware located, and this is the size of the resource. So basically, after I execute this function, you will see that the malware actually copies the resource into this allocated memory here. Okay, so let's run this, and you see that it actually copied the resource that it located into this allocated memory. Okay. Next, let's see what malware does. Okay, so the malware calls a function which I've renamed it as decrypt resource, because I know that what is the functionality of this function. So basically it's going to decrypt this resource that it located. So we'll see how it does that. Okay, so now if you see here, let's go to that address where, so you can see this is the resource. As you see, as I start executing, you will see here that it starts decrypting this resource, and you will see that it decrypts it to an executable file. Oops, let me quickly type that address here. Okay, so you see that this is the address where the resource was loaded, and you see that as I start executing this, you see that slowly it starts decrypting the resource, and you see that it is basically decrypting the resource to an executable file. So looking at the header, you can tell that the resource is decrypted to an executable file. Okay, and also it is using a single byte XOR encryption algorithm to decrypt it. So the key that is used here is this key here. Okay, so which is the hexadecimal value 41. 41 is the XOR encryption key using which it is decrypting the resource that it got from the resource section. Okay, so let's remove the breakpoint and just run this, and you see that it completely decrypted the executable file. As you can see here, this program cannot be run in DOS mode, and the P signature here. So it's telling that it is the executable. So basically, so far what the malware did was, so the malware identified the resource from its resource section, whose name, the resource name is localization and the resource type is Unicode. So basically, it decrypted the resource, which is nothing but an executable. Okay, so far this is what the malware has done. Okay, so now let's see what it does. So the next step the malware does is, once it decrypted the executable. So going back to our scratchpad here, you see that the malware process, in this case, this is the process that is hw.exe, at this point found the executable that it wants to inject. In this case, this executable came from the resource section, but it was encrypted to prevent some signature based devices to trigger that there is an executable embedded in another executable. In order to prevent that, this resource section was encrypted, and the malware decrypted that resource, which turned out to be an executable. At this point, this is what the malware did. Let's see what malware does next. Now it calls a function called hollow process injection. Now based on the functionality, I know what this function does. Okay, so let's get into this function. This is the function responsible for performing the hollow process injection. So let's get into the function and see how exactly the malware performs hollow process injection. Okay, so the first thing the malware does is it creates a process, okay, in the suspended mode. In order to understand what process it creates, okay, in order to understand what process it creates, we can look at the first parameter here. The first parameter here will tell you what process it's creating. Okay, so you see that it is going to create a process svchost.exe, okay, in the suspended mode. Okay, so just to show you, I'll also show you a tool called Process Explorer. As you can see, at this point, we have not run that function yet. So hw.exe is not created svchost.exe yet. But after I run this function, okay, you will see that hw.exe created a new process, svchost.exe. And also, if you look at this process in the Process Explorer, you will see that svchost.exe was created by hw.exe, and you see that it's in the suspended mode. Okay, so that confirms that the process svchost.exe is in the suspended mode. So if you remember, this was the first step in the hollow process injection. A malware process creates a legitimate process in the suspended mode. Okay, so that's exactly what it did. In this case, the legitimate process is svchost.exe. And then the malware gets the thread, it calls get thread context API call. So what it does is, using this API call, it can get the context of the suspended thread. So the thread that whose context it is getting has a handle of 44. Handle to the thread is 44. If you look in Process Explorer, if you right click it on properties and you look at the handles, as you can see here, the handle 44 is the handle to the thread of svchost.exe, whose process ID is 1568 in this case, which is a suspended process. As you can see, it is basically getting the context of the suspended thread. And this thread context is basically stored in a structure called context. We'll talk about that in some time. So why it's doing that. Okay. So at this point, just remember that it is trying to get the context of the suspended thread. And then next, what malware does is it uses it calls the read process memory API call. Using this API call, it can read the process memory of a remote process. In this case, it is reading the process whose handle is 34. The first parameter tells that the handle to this particular the process from which it is reading is has a handle of 34. So what is that process that has a handle of 34? Again, if you look in Process Explorer, you see that the process handle 34 is nothing but the handle to the process svc host.exe. So basically it is going to read from the process memory of svc host.exe. So okay, and then what is it going to read is the second parameter. So it is going to read from this address here, 7ff d44008. So what is this address? Okay, so in order to know what this address is, let's again go back to Process Explorer and see what this address is. Okay, let's go to properties, because it's reading the remote process. It is reading the process memory of svc host.exe. Let's see what is at that address. Okay, you see that there is a structure which is loaded at this address. There's a structure called PEB, which is the process environment block. You see that it is loaded at the address 7ff d4000. And if you see this, it is reading an address 7ff d4008. So basically what it is doing is, it is trying to read offset 8 from the PEB structure. It is trying to read offset 8 from the PEB structure, which is this address here. Now, what is this address at offset 8 from the, what is this value at offset 8 from the PEB? Now, this value here tells where the executable is loaded in the memory. In this case, this is in the little endian format, so the way you read it is 01000000. Now, by malware reading this value, it knows that where svc host.exe is loaded. In this case, malware knows now that after reading this memory, it can know that the svc host.exe is loaded at the address 01000000. To verify that, you can actually see here that that 1 followed by 5 zeros is where the svc 1 followed by 6 zeros is where the svc host.exe is loaded. Now this PEB structure contains that information in the offset 8. As you can see here, 10000000 is where svc host.exe is loaded. So that's what the memory, that's what the malware is trying to read. Okay, and the third parameter tells you where it will read that value. In this case, it will read that value at this particular address here. Okay, so as you can see here, this address doesn't have any value at this point in time, but after I execute the function, you will see that the malware read the value from the remote process, read the PEB structure from the remote process, and determine where the svc host.exe is loaded. At this point, the malware has the base address where the svc host.exe is loaded. Going back to our diagram here, at this point, the malware knows where svc host.exe is loaded. Malware now knows this address, which is something like 1 followed by 6 zeros, right? So this is the address where svc host.exe is loaded. Okay, now how did it get that? Basically, it got this by reading a structure called PEB. By reading the 8th offset from the PEB, it got to know that svc host.exe is loaded at this particular address. Okay, so why malware wants to know this address? Because I told you the next step is to deallocate this memory. In order to deallocate the memory, it has to know which address to deallocate. So in order to know that, it determined the base address by querying the PEB. Okay, so then at this point, the malware has the base address of the svc host.exe. Next, what malware does is malware resolves a function. So what function it is trying to resolve is in the second parameter. Okay, so if you look here, it is trying to resolve the address of the function nt-unmap view of section. Now this is an API call that can be used to unmap a particular section of memory. Okay, at this point it is not calling this function, it is just resolving the address of this function. And then you see that this is where it calls the nt-unmap view of section, and it is telling the unmap this particular section here in the process whose handle is 34. Meaning, if you remember the process handle, if you remember, let's go to that. Okay, if you remember here, the process handle 34 is the handle to the process svc host.exe, and if you see here, it is trying to unmap this address, the second parameter, that is 1 followed by 6 zeros, from the address from the process whose handle is 34, which is svc host.exe. And if let's go to the process hacker again, go to svc host.exe, just to show you again, svc host.exe is loaded at this address, which is 1 followed by 6 zeros. Now it is going to unmap this section of memory. So after I execute this code, right, you see here, now after I unmap this code and hit on refresh, you will see that memory has been unmapped. You no longer see svc host.exe in the memory. So as you can see, at this point, the malware hollowed out the process. Okay, going back to our diagram, at this point, the malware actually deallocated this memory here. Okay, so deallocated this memory here where svc host.exe is loaded. Okay, deallocated this memory here. Okay, as mentioned in the hollow process injection steps. Okay, so now let's see what malware does. Next, the malware calls virtual alloc ex API call. Using this API call, the malware can allocate a memory in the remote process. So in which process it's allocating the memory is the first parameter, which is the handle to the process, in this case 34, which is svc host.exe that we know. So, and the second parameter tells where in the remote process it has to allocate the memory. In this case, it is allocating memory at an address 4 followed by 5 zeros. Okay, and it is also allocating a memory with a page execute read write permission. Now after I execute this function, let's go to this here, you see that there is no address at this point. Before executing the function, there is no address which is 4 followed by 5 zeros. This is 4 followed by 4 zeros, not 4 followed by 5 zeros. You see there is no address at this in the address in svc host.exe. But after I execute that function, you will see that if I refresh it, you see that there is a memory that is allocated with a read write execute permission, which is 4, and the memory is allocated at this address, which is 4 followed by 5 zeros. At this point, it is initialized to 0. You see that address is initialized to 0 now. Okay, let's see what malware does. Now at this point, going back to our diagram, the malware now allocated a new memory. Previously svc host.exe was loaded at this address. In this case, it allocated a new memory which is different from where the svc host.exe was loaded. Okay, in this case, it loaded it to an address 4 followed by allocated a memory at this address, which is 4 followed by 5 zeros. Okay, and if you remember, the peb is still pointing to this particular address here, which is where the svc host.exe was previously loaded. Okay, and then let's see what malware does. Now the malware calls write process memory, using which it can write some content into the remote process. Okay, so what process it is writing? Again, the first parameter tells you the handle to the process, which is handle 34, which is nothing but the process 34 is svc host.exe, which is a suspended process. Okay, and where it is writing, the second parameter tells you where it is going to write. In this case, it is going to write to the remote process at this particular address, that is 4000 something, 4 followed by 5 zeros, that is this address. It's going to write into this it is going to write into this address here. Now if you remember, this is now zeroed out, but after after we call this function, you will see that, and it also, and you will see that something will get written into that address. Now what is it writing is the third parameter here. The third parameter in this case is the executable that it decrypted from the resource section. I mean, not the executable completely, but this fourth parameter will tell you the size that it's going to write. So basically, from this address, that is starting from this address, it is going to write 1000 bytes in hexadecimal. That is 4096 bytes, I guess, 4096 bytes, which is basically it is writing the P header now, just the header. It is just writing the header in this particular case. Okay, so after I execute, let's go to this process here, and this is svchost.exe. Let's refresh it, and let's see what we have here. And you see that at that address where it allocated the memory, it wrote the P header. As you can see, it just wrote the P header here. There is no other content here at this particular point in time. Okay. Now let's see what it does. Now the malware writes each and every section. This is the place where it writes. Once it wrote the P header, it's going to write each and every section of the executable file. Okay, so let's look at that. You see that it is first writing the text section. Okay, then you see that it writes the R data section. Okay, and then you see that it is writing the data section. At this point, it has written all the sections. Okay, at this point it has written all the sections. So let's look at that. Okay, so let's close it and refresh this here, and you see that as you can see, here, it has written the entire executable into that address where it allocated the memory. Okay, going back to our diagram, as you can see, it allocated a memory at this particular address, which is 4 followed by 5 zeros, and then it wrote this malicious executable into this address here. Okay, into this address here. At this point, the process executable of svchost.exe is now replaced with the malicious executable. Okay, but remember that the PEB's offset 8 was still pointing to this particular address. Okay. Now, what the malware is doing is, it is reading the PEB. Basically, it is reading the PEB, adding 8 to the PEB, and then writes some data into that address. Okay, so what is it going to write, and where is it going to write? In this case, it is writing to the process, writing to the process whose handle is 34, that is svchost.exe, and this tells you where it's going to write. In this case, it's going to write to an address which is 7FFD4008. If you remember, that address is offset 8 from the PEB. So in this case, the address is still, if you see this here, the address is still pointing to the address of svchost.exe, which was loaded when it was first loaded. It is still pointing to the address where svchost.exe was loaded first. Okay. Now, what the malware is doing is, malware is going to write some data in this address here. Okay, we'll close that. Let's refresh it. And what we'll do is we'll run this code here. And what it's going to write, okay, what it's going to write, let's see. Okay, after I execute this code, you see that, let's go there and go to refresh it, go to PEB, look at the 8th offset here. I think this one here, you see that this is offset 8. In this case, it overrode the address where the svc host.exe was previously loaded with the address where a new executable was, where the malicious executable was injected. At this point, the peb is pointing to the base address. The peb is pointing to the injected executable. Okay, the peb is actually pointing to the injected executable now. Okay, so which means the peb which was pointing here is now pointing to this new malicious new memory location where malicious executable is injected. Okay. Now, let's see what malware does. Now, the malware actually sets the context of the suspended thread. Now, what is it setting? If you remember, I told you it initially got the context of the suspended thread by calling the get thread context API. Okay. In this case, it is setting the thread. Before that, it is actually setting the value in this context structure, value underscore EAX, with the address of entry point of the malicious executable, with the address of entry point of the malicious executable that it injected. So why is it doing that? So that by setting this context, the EAX of the suspended thread will contain the address of entry point, the start address where the thread should start executing after it's resumed. So basically now what malware did was the start address of the suspended thread, it made the start address of the suspended thread to point to the address of entry point of the injected executable. So this executable was injected, the start address of the suspended thread is made to point to the address of entry point of the malicious executable. Okay, and then the malware calls resume thread API here. So after I call this function, you will see that the malware resumes its thread. Okay, so but before that, let me show you that the svc host.exe in the process explorer is still in the suspended state. Okay, after I resume the thread, you will see that it's no longer in the suspended state. It is now executing the malicious code. Okay, as you can see, it started executing the malicious code. Now, this is how the malware performs hollow process injection. Now let's run this completely. Okay, and see what happens. Okay, so I've ran it completely. Now let's look at the process listing, and you see that the svc host.exe is running on the system. So let's look at the process explorer as well. Let's close this, and if you see, the svc host.exe is running on the system. Now, if you look at this, you see there is nothing suspicious. If you are an incident responder or if you're a normal user looking for any process that is running from a non-standard path, there is no process that's running from a non-standard path. It won't create any suspicion. As you can see, one of these svc host.exe is a malicious executable. So we'll see how to detect this kind of hollow process injection techniques using memory forensics in the next demo. Okay, so but as you can see here, how the malware actually disguises its malicious process as a legitimate process here. So that way, now one of these svc host.exe is executing the malicious code. Okay, just to show you that this suspended, when the suspended thread is resumed, it starts executing this malicious code which was injected here. Okay, and this malicious code can be any code which performs malicious actions, like this code could be stealing sensitive information from your system, or exfiltrating data from your system, or it might be downloading additional components. But it look like svc host.exe is doing all the malicious actions. This is one of the reasons why attackers use this kind of code injection technique, so that the malware can blend in with the legitimate process. Okay. So before I conclude, also another thing, in case you are interested in what is that code that is injected, you want to analyze it, there is one way that you can extract that code. The code that it injected into the remote process memory, you can actually extract that code from the executable. So you know, I told you that this is the this is where it decrypted the resource. So let's try to decrypt that the same way the same way how malware decrypts this resource. So what I'll do is I'll save all this resource into a folder. I'll call it rsrc. Okay, so that will save this resource here. As you can see here, this is the resource. The .bin file is the one that is the resource, which is the encrypted resource. Okay, now let's try to decrypt this resource. I'll copy this into the desktop, and this is the script that can be used to decrypt the resource, which is here. As you can see, if you remember, the key used to decrypt the resource was 41, right? I've hard coded that key, and it used a single byte XOR decryption. As you can see here, this is the function that does the XOR decryption. And in this case, the script takes the resource file as the input and then decrypts it and then writes it to a file called out.exe. So after I run this code, okay, so I'm decrypting I'm giving the resource file as the input, which is data.bin, and you see that it decrypted the file to out.exe. Okay, so just run the file command and you see that we successfully decrypted the resource that we extracted from the resource section of hw.exe, which is now an executable. Now you can take this executable, analyze it, run it in a sandbox, or reverse engineer this executable to see what that injected executable actually does. Okay, just to show you that I can open that executable in the PE view, just to show you that it is a legitimate executable. As you can see, it's a legitimate executable, and if you look at its input address table, you see that these are all the functions that it's going to call. So which confirms that we have successfully extracted the executable from the resource section the same way the malware extracted it. Okay, so in the next demo, we'll see how to identify this hollow process injection using memory forensics.